All right, so I want to start out this. We're going to do 3-5b, which is a new way of dividing, a different way of dividing. Now, we don't just teach you the second way of dividing because this only works sometimes. The long division we showed you yesterday always works. There's certain situations where this won't work, so we don't want to do it this way. What I want to do, so just kind of reviewing what we did here, if we kind of just look at above, we had x cubed plus 27. So x cubed plus 27, we're dividing by x plus 3. We did put zeros to hold the places for x squared and for x. We had to hold those places in there. And when we divided, we always looked at the first term, x cubed divided by x was x squared, and then we multiplied, so we got x squared times x was x cubed. And then we took x squared times 3 to get 3x squared down here. And and then we had to switch the signs and add straight down. And we did that a few times. So we got, -3 here. And then at some point, we dropped the 0. We had 0 plus, it was -9. We switched to plus 9. So 0 plus 9 was 9. And then at some point, we had a 27. We switched to -27. And we added, we got 0. So I want to kind of look at those as we go along here. Let me see if I can get rid of all those marks I just made. Okay. Now today's it's just a different way of organizing it is kind of the idea. So what we're going to do is we're going to start with I'm going to draw a line here. So I'm going to start with this problem. I'm going to say put a box, and I'm going to put what the root of this is. So x plus 3, the root or the 0 of that would be -3. So I'm going to put a -3 in there, make a box out of it. And really, we could strip away the variables. This whole time, we were always adding and subtracting just the coefficients. It was just as long as they were lined up, as long as the x squareds were lined up, the x's were lined up, we could add or subtract them. So as long as we keep them lined up, we don't have to worry about it. So what I'm going to do is I'm going to look at this guy right here, and I'm only going to write down the coefficients. So the coefficients are 1, and then a 0, and then a 0, and then a 27. What's happening here? Let me go back. I'm off the screen. So 0 and 27. I didn't know there was an n there. Sorry. Okay, let me go back. We'll have to squeeze this a little bit. So 1, 0, 0, 27. Good, we fit it in there. So 1, 0, 0, 27. I don't normally like to have that squished, but we have to. And with this is called synthetic division. So what we're going to do is we're going to drop the first number straight down. So the first number, just add it, or drop it straight down, 1. Now I'm going to take 1 times -3. So 1 times -3 is -3, and then write that in here. So we're going to fill in the numbers. The second row of numbers, we're going to fill them in as we go, but we have to find them. So we drop the first number down, and we multiply to get -3. Now 0 plus -3 is -3. Now multiply by -3, that gives you the next number, 9. Add straight down, 0 plus 9 is 9. So we're always adding straight down. And then we multiply by this root up here to find the next number. So I got 9. 9 times -3 is -27. Add straight down is 0. Now notice, at some point we had 0 minus 3, and we got -3. Let me see if I can color code this a little better. Move some stuff out of the way here. And then pick a different color. So at some point we had 0 plus 9 equals 9. 0 plus 9 equals 9. And then at some point we had 27 plus -27 equals 0. We're doing all the same things. It's just we got rid of all the variables and it made it simpler. The problem is that answer down there, my final answer is just numbers. 1, -3, and 9. What do those numbers mean? Well, look at the coefficients over here. 1, -3, and 9. So what's going on here is this, all the way to the right, the first number is the remainder. The second number from the right is a constant. This is the x term. This is the x squared term. So it'd be 1x squared. minus 3x plus 9, and then no remainder, which is what the answer is up here. Okay, so that's kind of the whole idea of synthetic division, is we're just stripping away the variables and looking at the coefficients only. Let me switch this out here. So I might only do a couple of these. I don't want to spend a lot of time just because it's a 5-minute video already. But this guy here, now I'm switching to a different kind. I'm going to be drawing with called Screencast-O-Matic is what I'm recording with, and when I draw with that, it's not as clear. I was just drawing with the Snip app. But so anyway, on this one, if I wanted to divide, this guy right here, I want to divide that by, I'm going to put the root on the outside. So the root would be a 3, because x minus 3. So the 0 of that is 3. And then only put the coefficients down here. So I got 5, negative 6, 4, and negative 1. Draw a line. So now the second row of numbers, I don't know what they are yet. I have to find them. So the first step is always just drop the first number straight down. So 5. Now multiply 5 times 3 to find the next number that I need to write in the next row. So 5 times 3 is 15. So we're adding straight down, multiplying across. So when I add straight down, I get 9. And then 9 times 3 is 27. Add straight down, 4 plus 27 is 31. Multiply by 3, that's 93. Add straight down, 92. Now, it did not end in a 0, and that's okay. The first example we did ended in a 0. That meant it was a factor. So this right here is my remainder, meaning that x minus 3 would not be a factor of that cubic, the 5x cubed, so on. But that's my remainder. Then just count your way up. So constant x squared. So my answer, squared, would be 5x squared plus 9x plus 31. Oops, I need to make that a little bit bigger. 31. Now the remainder of 92 means I'm going to have the remainder of 92 over what I divided by. This is what I divided by. So over x minus 3. Don't put it over 3 because that's not really what you divided by. That's just the root that we used. Okay, so that's kind of the process the whole way through here. And we'll ask them different questions like, is it a factor? Well, that last number on the end, so this number right here tells you if it's a factor. If that is 0, that means there's no remainder. It is a factor. If it's 92, like this one is, not a factor. Okay. So let's see, I gotta clear this drawing here. So if you want to keep looking at it, pause your video. I'm gonna clear it, and then we're gonna go down. Let's see, I think that one. If you want to open up the completed notes, it might help to see these. I want to get to something new. I want to show you maybe something new. This one here, make sure, circle this. So this guy right here, make sure when you write your coefficients, like I would do 2 on the outside, that's the 0 of this guy. But then I would do 1x to the 4th, no x cubes, negative 3 x squareds, no x's, and then negative 10. Okay, so make sure you fill the zeros for the stuff that's missing. That's the important part, is fill those zeros for what's missing. Let me clear this drawing now. I'll go down to here. Now this is a slightly different question. It says factor completely. Now if you were doing numbers, and and I said take 50. Let me get the. I said factor 50. Well, you might start with dividing by 5. And you take 50 divided by 5, you get 1, and then this is 5, 0, goes into 0 times, and the quotient would be 10. Well, 10 is not factored completely because 10 can be split up into 2 and 5. So now I've got my complete factorization, 2 times 5 times 5. So I have to keep going. Okay, so kind of the same idea here is, let me clear this drawing. Whoops. Give myself some room here. Okay, so I want to factor completely, but I need to divide first. So it says given the x minus 2 is a factor. So right off the bat, I'm going to use synthetic division with the root 2, 1x cubed, negative 16 x squared. That does not look nice, but plus 70. What am I doing? Get back there. Oh, it needs a negative 16. I'm forgetting what I'm doing here. 76 and then negative 96. And let's see. Got a lag on it when I click on stuff. All right, so now I'm going to drop the 1. Just drop that one straight down. And then 1 times 2 is 2. Negative 16 plus 2 is negative 14. Negative 14 times 2 is negative 28. Add straight down, that's 48. Positive 48. Multiply by 2. Find the next number, 96. And I get 0, which I should not be surprised by this. It needs to be 0 by this. Try and draw an arrow. Because they said it is a factor, so this needs to be 0. If it's not 0, I messed up. So what's left here is I've got these coefficients are 1x squared minus 14x. Not sure why this is so bad. And then plus 48. Think, how can I factor that? Well, that would be two numbers that multiply to give you 48, and when you add them, you get negative 14. So they must both be negative, and what's that? 8 and 6. So this factored to x minus 8, x minus 6, but don't forget your one factor over here. In fact, let me change the color and make it stand out a little more. So pull this over, and this would be x minus 2. And there's the complete factored form of that binomial, or that cubic. Yeah, that was a cubic. So when it does that, they're giving you a hint, x minus 2, use that, do synthetic division with that, and then take what's left and keep going with it. Okay, so I'm going to stop there just so the video is not too long. But if you want to see more examples, open up the completed notes. That'll help you see more examples and hopefully follow along. And eventually we'll talk about, like, why don't we do this all the time? Well, it doesn't always work. There's certain situations where it doesn't work. But yeah, we need to know both ways. So anyway, hopefully that helps.